This is Gaia BH1, the closest known stellar mass black hole, located in the Milky Way galaxy, just over 1,500 light years away. And this is just one type of black hole. So, who wants to see 16 more types of black holes? Yeah, me too. We're about to get spaghettified by every flavor of black hole, from micro to super extremal black hole. Gaia BH1 is a great starting point because we discovered it while completely ignoring it at first. In 2022, scientists noticed something strange while analyzing the European Space Agency's Gaia mission data. The star they were studying seemed to be orbiting something invisible. That invisible object turned out to be the stellar mass black hole Gaia BH1. It contains about 9.5 times the mass of our Sun, compressed into an unbelievably small region of space. A black hole's event horizon is the sphere surrounding the black hole that traps everything that enters it, including light. For Gaia BH1, it's only 56 kilometers in diameter. You could drive across it in half an hour, if you could drive across the surface of a black hole, which I wouldn't recommend because, death. Now, what's somewhat odd about Gaia BH1 is that it's dormant. It's not devouring everything around it. The only reason we know it exists is that we can see its companion star being dragged around by something imperceptible. One of the scientists explained the relationship as, take the solar system, you put a black hole where the sun is, and then you put the sun where Earth is, and you get this system. But as unique as this discovery was to us, stellar mass black holes like this, they're the bargain bin version of black holes. Ordinary, Bobby Basic. Hundreds of millions of them in our own galaxy. The universe is filled with quintillions of them. So, this, that, and therefore today, we are going to see just how many different types of black holes we can find. How big they get, how small they get. Did you know that we could potentially create micro black holes right here on Earth? Would that lead to the destruction of the planet? You'll find out. And you'll see how weird black holes can really get. Stupendously large black holes, fuzzballs, and white holes. Sounds like a 1940s game of marbles. And yeah, that's just a few of the ones coming up. By the end of this video, you'll see just how big a black hole can get and just how extreme a super extremal black hole is. But first up, picture this. The year is 1783. You're in Yorkshire, England, and you can't sleep. A big, dark idea is keeping you up at night. You are Reverend John Mitchell, both a preacher and a scientist, a seismologist. You're a guy who builds his own telescopes, and you're getting insomnia wondering what happens when a star gets so big that its escape velocity exceeds the speed of light. Well, you calculate that would only take something about 500 times the size of our sun for this to happen. What happens then to the star? If no light can escape it, wouldn't it become completely invisible? Like a dark star? Okay, now let's get back to our dark star. This is Cygnus X1. It's about 7,200 light years away from Earth, a stellar mass black hole approximately 20 times the mass of the Sun, formed from the collapse of a gigantic star. It's one half of a high-mass X-ray binary system, sitting right beside a supergiant star. And it wasn't until 1971 that it was proven to exist by a pair of British-based astronomers, becoming the first known black hole. Now, if you're wondering why it took so long to find the first actual proof of a black hole's existence, cut us some slack, Jack. This thing is literally 68 quadrillion kilometers away. That's 1.7 trillion road trips around planet Earth. And scientists were looking for something 90 kilometers across. And it's pitch black, sitting beside a supergiant star. Here's the thing about black holes. As embedded as they are in our popular consciousness and our sci-fi, whether it's a Christopher Nolan movie or 1990 Star Trek, in practice, we still don't know much about them. I mean, they're tough to find, and we weren't even able to take an actual picture of one until about 7 years ago. So, although we've been theorizing about them since the 1700s, and Einstein's theory of relativity predicted them in the early 1900s, and Oppenheimer modernized them in 1939, they're still a huge mystery. Scientists are actively researching them, winning Nobel Prizes for discovering them. So far, in our galaxy, we can prove there are two types: stellar mass black holes and the supermassive black hole monstrosity at the center of our galaxy. But there could be as many as 17 different types of black holes throughout the universe. What's cool about black holes is that even though we didn't get the visual receipts on them till the last decade, math said they'd exist over 100 years ago. Yeah, Carl Schwarzschild figured out the distance from a black hole's singularity to its event horizon in 1916, before TV was even invented, like with a pencil and paper. Now, for a lot of the black holes we'll talk about today, their study is in its infancy, so proving they exist is still an exhilarating work in progress. So, what do we know about black holes? Okay, this isn't actually a university course because you can kind of explain everything we really know about black holes to a kindergartner. Until you get to the math, and then, well, you really need a university course or a doctorate in physics. We know that common stellar mass black holes form when big stars, 5 to 20 times the size of our sun, run out of fuel and cave in on themselves in spectacular supernova explosions. The parts of these black holes we understand are fairly limited. We know that there's the absolute center, there's a single point of near infinite density and mass, a singularity where the regular laws of physics totally break down. Then there's the event horizon, the boundary that we can't see past, where gravity is so strong that not even light escapes. It's not even a physical thing, it's just the line where the escape velocity is equal to the speed of light. Now, the event horizon has a dark zone surrounding it called an event horizon shadow, about twice as big as the black hole surface, where distorted space-time around the event horizon causes light to be redirected through gravitational lensing. And surrounding the black hole is usually an accretion disk. This is a flat disk of hot gases and matter caught in orbit around the black hole. They orbit so fast that they superheat and spray light and X-rays everywhere. While the temperature of the black hole itself is near absolute zero, the gas surrounding it can be millions of degrees. Celsius or Fahrenheit, take your pick here. Some black holes also have what looks like a little tuft of hair called a relativistic jet or particle jet, where massive geysers of radiation and particles surge outward from the black hole's poles at near light speed. These jets can stretch hundreds of thousands of light years. If you're wondering what would happen to our very nice planet if we wandered into one, well, the jet is basically an intergalactic fire hose of X-rays, radiation, and supercharged particles. So, if it were anywhere near our solar system, yeah, that's an extinction level event. Say goodbye to the atmosphere and any creature with, DNA. Finally, there's a photon sphere. The light from the accretion disk gets bent by the black hole's immense gravity, which creates a bright, thin ring or proton sphere around the black hole. Think of it as really distorted images of the accretion disk. And that's basically it. Fewer parts than a Duplo set. Now, the fascinating thing about black holes is, theoretically, there's almost no limit to how small or how big they can be. How big? Let's find out. Okay, let's start with these little guys, the micro black holes. When the Large Hadron Collider fired up in 2010, critics had serious concerns that scientists might create a black hole in Switzerland. Yeah, there were protests, people charging that physicists could accidentally, destroy the planet. Now, while it's possible that scientists might create a microscopic black hole with the collider someday, it wouldn't be big enough to pose any danger. It would weigh less than a gram, and it would disappear in less than a trillionth of a second, thanks to Hawking radiation. So it is possible that we might be able to create a micro black hole right here on Earth, but it's going to be so small and short-lived that the most problematic thing about it is proving that it ever existed at all. Hawking radiation was, named after Stephen Hawking, who proposed that black holes actually leak mass and particles due to quantum effects near the event horizon. In short, he thought that black holes lose tiny bits of mass over long periods of time. You don't normally think about black holes evaporating, but they are, very slowly. The best way to study this phenomenon might be the super extremal black holes. If found, they could unlock understandings of the inner workings of a black hole and change physics forever. How? We'll get to that later, but first, let's talk about the earliest black holes, primordial black holes. Now, we just talked about these in a recent episode about Planet 9. If you've been missing Chase, that animated smart mouth who dies in space, well, he's in that video, looking for the next planet in our solar system. If you've already seen it, you might remember that one of the potential culprits behind the weird orbits of several trans-Neptunian objects could be a primordial black hole. That's right, there could be a grapefruit-sized black hole floating around the outer regions of our solar system. The idea behind primordial black holes is pretty awesome because they're ancient. They're as old as the universe itself, almost. The theory is that within the first second after the Big Bang, some of the densest regions of the brand new universe immediately collapsed into black holes. They could be any size, little tiny ones with less mass than a staple, or up to 100,000 times more massive than the sun. The littlest guys would have all been lost to Hawking radiation in the 14 billion years since the universe began, but there are plenty of others that could still be flying around, even potentially just out past Pluto. Okay, next up, mass-wise, are the stellar mass black holes that we all know and love, like Gaia BH1 or Cygnus X1. They land right around 5 to 20 times the mass of our sun. And then, after that, what's wild, for the longest time it looked like there was nothing between the basic stellar mass black holes and the monsters at the hearts of galaxies. But scientists recently discovered the intermediate mass black hole. They think, out in Omega Centauri. The scientists at the Max Planck Institute estimate that the black hole in Omega Centauri could have a mass about 8,000 times that of the sun. Which is kind of wild because that's way too big to be born from the death of just one star. So it's either devoured other black holes or stars or both to get to this size. The next size up is the supermassive black hole, the well-documented, humongous black holes at the center of every galaxy. They're so well known that they've created a developing field known as It's not easy to get a snapshot of a black hole, whether it's tens of millions of light years away or hidden right in your own cosmic backyard. In 2017, scientists attempted to take the first photos of black holes, focusing on two giants, the extremely distant black hole at the center of the M87 constellation, 55 million light years away, and the black hole at the heart of our Milky Way, Sagittarius A star. Trying to image these pitch-black objects was phenomenally difficult, but the solution was ingenious. Scientists used the Event Horizon Telescope to essentially turn Earth and its international network of radio telescopes into a giant planet-sized telescope that can see through multiple layers of interference. Synchronized using precise atomic clocks and complex algorithms, this idea was able to eliminate light pollution and produce an image of the glowing ring surrounding a perfect circle of darkness, the shadow of a black hole. In 2019, scientists dropped the first portrait of the M87 black hole, a supermassive beast 6 billion times the mass of the Sun. Just 3 years later, scientists used the work of Andrea Ghez and Reinhard Genzer, who won the 2020 Nobel Prize for mathematically proving a supermassive black hole existed in our galaxy, to reveal something much more intimate. This photo of Sagittarius A star, the supermassive black hole at the center of the Milky Way that's located just 26,000 light years from Earth. Imagine you spend 30 years tracking stars orbiting an invisible object at impossible speeds, pretty sure that something with 4 million times the mass of the Sun was hiding at the center of our galaxy, and then finally seeing it. Don't give up on your dreams, kids. Now, what will be the third black hole to be imaged? Well, that's TBD, but what other black holes could be out there? Well, how about ultramassive black holes are a class of black holes 10 billion times the mass of our Sun and beyond. That includes a black hole within the cosmic horseshoe system and Ton 618, a 66 billion solar mass black hole, and potentially the black hole in the Phoenix galaxy cluster, known as Phoenix A, which just may be the biggest black hole in the universe so far. Phoenix A's black hole may be so big it's actually a stupendously large black hole, a new classification for black holes over 100 billion times the mass of our Sun. This is on the upper limit of how big a black hole can get. Beyond this, things get extra theoretical and extra weird. And we can't just give them all a title board. So how about we just call them... Okay, the really weird theoretical black holes include the Schwarzschild black hole, a non-spinning, uncharged black hole, which is strange because all known black holes spin. Or the other non-spinning black hole, the Reissner-Nordstrom black hole, which has an electrical charge, which most black holes don't. Or the Kerr-Newman black hole, which spins and has a charge, as opposed to the Kerr black hole, which is actually just a spinning zero-charge black hole, which is most stellar mass black holes. Confused yet? Oh, hold on, it gets thought experiment weird. Other theoretical black holes include the string theory-based fuzzball black hole, which theorizes that black holes are giant, messy balls of yarn made of vibrating strings. Or the Ashtekar black hole, an eternally collapsing object where the collapse of a black hole stops and reverses into an expanding phase, potentially creating a new universe. That one's more philosophy than physics, but things get a bit Matthew McConaughey at this point. Also highly theoretical, the Gravistar, which looks like a black hole but is basically a series of shells packed with dark energy, which sounds like an egg and an egg and an egg, but all black eggs. Emu eggs. Did you know that emu eggs are black? Yeah, you do now. Or a regular black hole, which is actually a regular black hole, but with no singularity. From the outside, it would look exactly the same, but somehow the singularity wouldn't be a singularity. Sure. Is regular too regular for you? Well, then how about a white hole? It's essentially the complete opposite of a black hole, constantly expelling matter and energy outward. It's somehow a black hole working in reverse, like it's time reversed, running backward, spraying out matter and energy. This does break a lot of the laws of physics and thermodynamics. There's also a firewall black hole, which has a high-energy shell of particles, a ring of fire just beyond the event horizon. Imagine a tennis ball on fire scaled up to the size of a black hole. And finally, one of the most fascinating black holes we've ever hoped to discover. A black hole that spins so fast and picks up so much electrical charge that its event horizon disappears. No event horizon. Now we can see the guts of it. This might be the coolest thing we could ever study. A naked singularity, that infinitely dense point where physics breaks down, and it'd be fully exposed to you and me to study in the outside universe. For scientists, this would be a dream come true, as we'd be able to peer directly at the workings of the most mysterious objects in the universe. The singularity. Specifically, the singularity at the heart of the super extremo black hole. Now, there's almost no chance that this exists, but I do know one thing. If it does, scientists are going to figure out a way to image it, and it's going to be awesome. Look, most of these weird black holes and white holes are entirely theoretical. Beyond the stellar mass and supermassive black holes, there's still untold amounts of work to prove that any of these exist. Still, imagine if we could get some footage of these things smashing into each other. How awesome would that be? Well, that's a story for another What If.